Lesson 2.4, slopes of parallel and perpendicular lines. This entire lesson is something that you should have learned in Algebra 1. Granted, I know that a lot of kids forget what they've learned in Algebra 1, and I'm gonna teach it to you as if you haven't learned all of it. So some of it you might need to review and go over, but let's get started. So we're talking about slopes of parallel and perpendicular lines. So to start the lesson, it's going to start with a problem about slopes. I'm not going to go through this entire problem with you, but it says Pilar and Jake begin climbing to the top of a 100-foot monument at the same time along two different set of steps at the same rate. So the same rate, that's important. The tables show their distances above ground level after a number of steps. So Pilar has these, Jake has these. Notice that the numbers are different because the steps they are going up are different heights. So Jake's could be like this level and Pilar's steps could be like bigger. Or vice versa. So I want you to look at those and go over them and try to figure out their rate is the same. They're moving at the same speed, but the distance they're going is different. So it wants you to ask how many feet does each student climb after 10 steps? So try to figure out where they would be at 10 steps. And try to finish that question based on they're still going 100 feet, they're going the same rate as far as speed, but how far they're moving in distance, like vertical distance, is different. Example number 1, slopes of parallel lines. A hill and a gondola line 20 feet above the ground that goes up the hill both have a slope of half. When you first read that, you're like, okay, a hill and a gondola. Now, this isn't the gondola like in the river on the waters. It's the gondola like for like a skiing. So here, there's actually a picture. Here it is. So here's the hill. Just pretend like this is the hill, starting at ground zero. And the gondola is above that hill, 20 feet, I believe. Yeah, 20 feet above the ground. Now, all these little things are helping you. This is the equation of the line, the equation of the hill, the y-intercept, the y-intercept. So y-intercept of the hill, 0. The equation would be y equals slope times x plus that 0, but you don't need the 0 in the equation. The y-intercept is 20, so the equation is y equals, here's the slope, x plus that 20. Okay, so this is the visual so you can understand the question, but the question says, what is the geometric relationship between the hill and the gondola line? So I want you to think of that and figure out, so what? Why does this line and that hill, what do they have in common? So try to answer that question. And then you're going to try it. Suppose another line for a chair lift is placed at a constant distance c below the line. So here's the line. If let's say I went down 10 feet, and I went over here, down 10 feet, and I went over here, down 10 feet. It would create this other line. You have to explain, so what's happening to that other line in relationship to these lines? How does that affect it? What relationship does it have? And you can put your answer here and check it to see if you're on the right track. Theorem 2.13. Again, don't worry about remembering the 2-13 or 2.13 because it changes depending on the textbook. So 2, non-vertical lines. So these are vertical. We're talking about every line except vertical lines, okay? Non-vertical lines are parallel if and only if their slopes are equal. So I want you to envision a slope. If this one, rise 2, run 3, 2, 3, 2, 3, then the other line would have to go 2, 3, 2, 3. The slopes would have to be the same to make those lines parallel. So whatever one line moves, the slope, the other line has to match it. Rise and run the exact same amount so those lines are parallel. So that is true. P is parallel with Q. There's the parallel symbol. If and only if the slopes of line P equals the slope of line Q. The slopes must be equal, but there is a catch. It's when you have those vertical lines. Because a vertical line, rise over run, it rises, but it doesn't run. So that means it's an undefined slope. So both of these have undefined slopes. We don't really say undefined is equal to undefined. So we just say if they're vertical lines, they're parallel, but they both have to be vertical. Checking parallelism. That's a fun word to say. We need to know if lines are parallel. If you are given a graph There are a couple different ways. One, you can find the ordered pairs and do the calculation for slope, which I'll show you in a second. Or you can count, and you can like leapfrog count to figure out what the slope is. So we're going to do both because I want to make sure that you know how to do both. Here, let me move this. So we're talking about lines K and N. Let's start with K. I need a point on K that is very obvious. This looks like a very obvious point. And I need another point. This looks like a very obvious point. So find 2 points that are definitely intersecting with the graph paper, and then you need to count their rise. 1, 2, 3, 4, 5. And their run. 1, 2, 3, 4. So the slope of K, and I'm going to say slope, I use the M for slope. Slope of K, and I'm just putting a little subscript K, equals the rise over the run, 5 over 4. Now, if you've done this before, you know there should be a positive or negative slope. And so ask yourself, are you going like upward up the graph? And when I tell my students, I show them in person, and it's hard to show on the graph. On the video, I literally cover up the graph and slowly move my hand from left to right, just like you're reading a book. So cover up the graph and reveal it. And where that line is, if you can see the line going downward as you're revealing it, like this one is, if I'm revealing from left and I can just see this, revealing it, it's going downward. So I know that's a negative slope. It's going negative or down the graph because you always read a graph left to right. Okay, now I'm going to check, that's line K, and I'm going to put it, underline it in purple. Now we're going to do line N. Same thing, you need to find definite points. So this one might be a little bit trickier. Oh, there's one. There's a point. Notice I'm looking for them to cross, intersecting the graph paper exactly, perfectly marking up. So there's another point. So I'm going to count 1, 2, 3. And then I'm going to count vertically. 1, 2, 3, 4. Okay, so my slope of line N equals the rise over run, 4 over 3, and it's negative. Now, because I'm using this color and it's from my mouse, I'm going to double check my math just to make sure. Okay, it goes up 2, down 3, yep, that's 5, over 2, yep, that's 4. Okay, because it's hard to tell. So are these slopes the same? They're not. So they are not parallel. So I can say not, in my terrible writing, parallel. And there's the parallel symbol. Okay. You can also do this using the coordinates. If you don't have a graph, you're going to need to know how to do that because you're not always going to have the graph. So we're going to do that next. For example number 2, part 2, the try it, I'm going to go through and do this not by counting, but by using the slope equation. So I'm going to write the equation. So slope equals, and you might remember this, I'm hoping. It's a fraction, whoops, because you need the rise over run. So you have y1 minus y2 over x1 minus x2. Now, to be honest, a lot of teachers say y2 minus y1, x2 minus x1. It doesn't really matter. So I'll write them both ways just in case. Or, depending on your teacher, y2 minus y1, and then x2 minus x1. And again, I'm writing with a mouse, so I'm sorry, it's a little bit messy. Okay, so these are the slope equations. Basically, you're taking the y, the difference of the y's, and the difference of the x's. But just make sure, if you're using the second point at the beginning, then the first point, see the ones, have to be after. If you're using the first point at the beginning, then the second points have to be after. So let's do this. Lines M and Q. So M is here. We got to find 2 obvious points. That looks like one. And that looks like one. And you need those ordered pairs. So I'm going to say this point right here is an ordered pair of -1, 4. Without the coordinates, you can't really use the slope formula. So you need those coordinates. And then this other point is -4, and then up 3. So 3. So I'm going to find the slope of line M. So since I'm using M and I'm talking about M, I'm going to do a slope of line M with a small one equals. And I will take this and I'm going to say this is my first point, x1, y1, which would make this x2, y2. Every single time you are using a formula with coordinates, if you are not good at it, really good at it by now, you need to be labeling these every single time. The more you label them, the better or more accurate you'll be. So since most teachers use this one, I'll go ahead and use that one. So I'm going to take y2, which is the 4, minus y1, which is the 3, over, can you see the x2? x2 minus x1, and it is, they're double negatives, and that happens sometimes. I'm hoping you know that two negatives right in a row like that become a positive. So I have equals 4 minus 3 is 1. These two negatives together are going to become positive, so I'm just going to make a big, huge positive. Negative 1 plus 4 is 3. So I have a slope for line M as 1/3. 4 minus 3 is 1. Negative 1 minus 4, or plus 4 is 3. And you want to double check. This line is going upwards, so yes, it is indeed positive. So that's 1/3. Now I'm going to do the same thing, but for line Q. Line Q. I'm going to find 2 points that are obvious, very easily determined, like absolute for sure points. I'm going to go find another one. Just looks like right here. And I'm going to write those coordinates. So this looks like -4, -2. -4, -2. Luckily, I am getting a tiny bit better using the mouse, but not a ton. And then this point right here looks like it is 1, 0. Because you go over 1, but you don't go up and down at all. So label them, especially if you're getting new at this or not 100% confident. X1, I spoke too soon. I thought it was getting better. Y1, X2, Y2. And maybe I'm getting worse. So I'm going to go over here, and I'm going to do the work right on top of here because it's going to be, I'm running out of space. So I'm going to have the slope of line Q equals, use this same formula, find the difference of the y's, y2 minus y1. So y2 minus y1, and again, it's going to be a double negative, that's okay, over x2 minus x1, x2, which is 1, minus x1, double negative again. Okay, so I've got the slope of line Q, and there, got it all set up. So the slope of line Q equals 0. I'm going to put these two negatives, make it a big positive. 0 plus 2 is 2. 1 minus a negative, so I'm going to make these together, make it a big positive. Two negatives in a row like that. 1 plus 4 is a 5. And I'm going to check just the negatives and positives. It does indeed go up, so it is a 2/5. And so the question says, are these lines parallel? This is showing all my work, every step of it. And if I stop right here, I never even answered the question. You have to answer the question. So if the lines are parallel, they would be exactly the same slopes. They're not, so they're not parallel. Theorem 2-14 or 2.14. Two non-vertical lines are perpendicular. So no longer are we talking about parallel, we're talking about perpendicular. That means they intersect at a 90 degree. They are perpendicular if and only if their product of the slopes is -1. So a lot of times when you're talking about slopes and perpendicular, people consider this perpendicular slopes have to be opposite reciprocals. Opposite reciprocals. It's taking forever to write this. Opposite reciprocals. So this capital T that's upside down, that's the symbol for perpendicular. So perpendicular slopes have to be opposite reciprocals. Well, what does that mean? That means, here's the example. If I had 1/2 as a slope of a line, and I had another slope that was -2, okay? These are opposite, meaning they're opposite signs, and it's taking the fraction and flipping it over. So this is just a -2, but think of it, I'm going to do this like dash, so it's kind of like invisible. This is -2 over 1. So -2 over 1 flipped over, that's the reciprocal, and the opposite sign. So these together are opposite reciprocals. If I multiply these together, there's my little multiplication dot. If I multiplied those together, this would give you indeed -1. And that's what it's talking about. So the slopes have to be opposite reciprocals, or their product has to be -1. The exception to the rule of opposite reciprocals and multiplying out to give you a -1 is if the lines are perpendicular are vertical and horizontal. So the exception to the rule is if the lines are vertical and horizontal, because remember, vertical angles have undefined slope, and this slope is 0. So you can't say that they're opposite reciprocals of each other really, and they don't multiply to give you a -1. So this is the one exception. They are perpendicular, vertical and horizontal, perfectly vertical and horizontal, or they're perpendicular if the product of the slopes equals 1. To check perpendicularity, you have to find the two slopes. Again, if you have the graph, go ahead and count, check the slopes, and then see if indeed are they opposite reciprocals. On the next problem, it asks you the same thing, check if they're perpendicular. But on this one, I want you to use that slope formula that I did with parallel lines. Find the slope. I'll write the formula just in case you've forgotten it. So slope equals, we'll do the y2 first. y2 minus y1 over x2 minus x1. So use that slope formula. Look for each of the slopes, calculate each of the slopes, and then see if the slopes are opposite reciprocals. Writing equations of parallel and perpendicular lines. If you're not very good with equations of lines, or if you struggled in the past, really go back and review these. There are lots of resources, and your teacher can help. I can help finding those resources. But here's an equation of a line. It is given to us. It says, what is an equation of a line through point P parallel to line L? So first of all, if the lines are parallel, then the slopes have to be the same. So there it is. There's my slope. So I'm going to click this solution and let you see it. So it says, hey, the slope has to be 1/2, which is what I just said. But we don't have the b. We don't have the y-intercept. And that's where you're going to take some numbers and plug them into the y equals mx plus b, or slope-intercept form of the line. If you're good at point slope equation, you can use that as well. Lots of kids prefer the y equals mx plus b. So notice you take this slope, m, which is what we have from this line, and then you plug in the x and y, the 4 and 1. So here's the x, 4, here's the 1, y, and then you solve for b. Once you have b, then you just write the equation. There's the half, there's that new b, and that's the equation if a line is parallel. You would do the same idea if it was perpendicular, but if it's perpendicular, you would have to have the opposite reciprocal slope. So let's check this next problem. Equation through point B if it's perpendicular. So same idea. Take this slope, but you don't want it to be 1/2. You want it to be the opposite reciprocal, and then plug in the 4 and the 1 for the x and the y. And the solutions are here step by step for you. And then it asks you to do it on your own. So there is no graph. If you want a graph those. Feel free to graph those anytime just so you can visualize it. But basically, you have the equation. Here's the slope. That -3 is a slope. Here's your 2 points, the coordinates, or the point 3 and 1, x and y. And then you have to solve for the new b, or y-intercept. Concept summaries. Bottom line, parallel lines have to have the same slope. Perpendicular lines have to have their slopes opposite reciprocal, or they multiply to give you a -1. The only exception is vertical. So if they're parallel, if they're both vertical, they are parallel. If one's vertical and one's horizontal, then they are perpendicular. So parallel lines, same slope, perpendicular lines, opposite reciprocals. I hope that helped.